We're talking about something called a perpendicular bisector. All right. So with the idea of a perpendicular bisector, the first thing is that you read a perpendicular. So what it means to be perpendicular is two lines intersect and they form 90-degree angles, right angles. So we could put four boxes all the way around, and some people like that. I'm not one of those people. Most that I do is like vertical angles to reinforce maybe vertical angle ideas. But they're all 90-degree angles. And that's what makes it perpendicular. Now, the bisector part is a little bit different. So what the bisector does is you can one of two ways. And for this one, it actually goes both. It's going to split A to this center point. We'll call it C. A to C and B to C are equidistant away. That's what makes it a bisector, because a bisector cuts anything into two equal pieces. Okay? So when you hear perpendicular and bisector and we join them together, it means we have a right angle and it cuts it into two equal pieces. Now, with that same step, I think we could call XC equal to YC. Now, XC and YC may not be equal to AC and BC, but we do know that they are equal to each other if it cuts through, if it bisects that way as well. Sometimes it does, sometimes it doesn't. And it really will depend on your information that they give you, okay? So for here, X is on the same distance from point A as it is from point B. So they're telling you this distance is the same as that distance. Okay? And point A and B are the same distance from the intersection point. So right here at C. So we know this and that. And yeah. That's what we're doing with our perpendicular bisector. It's a tool that's going to help us apply information to these types of problems. So how can we help with this? So it says WY. So this line coming through, this line, they're telling you, is a perpendicular bisector. So I don't know anything from XW and XY. I don't. But I do know that it's coming in at a 90-degree angle if it's a perpendicular bisector, okay? And it bisects this piece right here. That's how we know what is equal. So I know this side is going to be equal to that side. And if this side is 18, that's going to make that side 18, right? Okay. Now let's go travel back here. If a point on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. All right. So X is the same distance away from A and B. So what we could say here is this is going to be equal to that. So whatever this is labeled, that is labeled. Now, if your brain is starting to click a little bit and it's hey, do you remember? Yeah, of course I do. Welcome back. Now, if your brain's starting to go off a little bit here, and you start to see a right triangle happening where we could use something, that is actually what's coming in our future. Now, we haven't done it yet, but it is potentially going to come. So AW, we have as 27, AX is 18, and AB, make sure you take the AX plus BX, so AX plus BX equals AB. Man, that's got to sound familiar, like the segment addition postulate. A piece plus a piece equals the whole thing. So, 36 is AB. All right. Now, this time, BD, so once again, this is coming through and cutting into two equal pieces on this side. So if this is 30 over here, this is 30 over here, okay? This is 50 over here. We're going to post this as 50 over here. So we have this side is equal to that side. We're going to have this side is equal to that side. And then we have the middle is equal to the middle. All right. So now that we have everything labeled that we know, we could find BC. BC is 40. What about DC? Well, DC is 50. AE is 30. And then AC all the way across again is going to be 60. Now we're going to start pulling in to find BE and DE, but that's going to be our second step. So once we have all of that, our second step's going to come along, okay? And our second step, if a point is equidistant from the endpoints of the segment, then it's on the perpendicular bisector of a segment, okay? So if a point is equidistant from its endpoints of the segment, then it is on the perpendicular bisector of the segment. So what we're going to do is we're going to start to use the Pythagorean theorem to solve for this length right there by doing a squared plus b squared equals c squared. Guess we don't really need the squareds, do we? Let's get rid of those. So we have A, B, and C. And understand, we could put B here. We could put A there. We can flip-flop A and B till we're blue in the face. But the one thing we cannot do is move C, because C always has to be across from the 90-degree angle. So that's how we know this has got to be C, and it can't be anything else. Okay? So let's try and use that. So if that's the case, we know AD is 10. We know BD is 6. Find the length of AC. All right. Well, first thing we can do is we can do A squared plus B squared equals C squared. Because we know this is a right angle, and if this side is a right angle, and we have a straight line right here, my students definitely know that if we have a straight line, it's 180 degrees. So if one of the angles is 90, plus the other angle, well, the only other logical number is 90, because 90 plus 90 equals 180. So this angle has to be 90 degrees as well, okay? So we can use Pythagorean theorem because we have a right angle. All right, now our A is going to stay A. Our B is going to get replaced with a 6, and I'm going to put it in parentheses, and our C is going to be 10. Not that it needs to go in parentheses, but whenever you're using exponents, it's helpful, especially if you have signs you have to take care of. It will help you with those as well. And we're going to get our ever-famous Pythagorean triple. And it's called a Pythagorean triple because A squared equals 64. And when we take the square root, we actually get a beautiful number of 8. So we know A equals 8. Okay? So because of that, and we know that these are equidistant from each other, we can say, and let's do this. We can do substitution here. We just plugged our numbers in. Exponents, took care of our exponents. Then we did subtraction, property of equality. I guess you could, well, we did this to zero out the 36s. And I don't want to say square root yet because this is actually square root is the resultant of doing the square root. So that's how we got here, is because we did the square root of both sides. Okay? Now that we have that, we know that the converse, if a point is equidistant from the endpoints of the segment, then it's on the perpendicular bisector. So we know this side is equal to that side, so we know BD is the perpendicular bisector of AD. So we can say BD is the perpendicular bisector of AC by the converse. And I don't know how much of this is, most of it's off the screen on the phone. Dang. That's the converse of the perpendicular bisector, which will tell us that if AB is 8, then BC is also 8 by the definition of a perpendicular bisector. Because now that we know it's a perpendicular bisector, we can use that perpendicular bisector definition to say that AB is 8, then BC has to be 8 as well. And then we can do the segment addition postulate to finish off and say 8 plus 8 equals AC, 16 equals AC. Substitute and simplify. So that would be our proof for this type of problem. Okay. Now, do we need all of that? I don't know. I always like to explain every step so that there is no confusion on where something comes from. If it's too much for you, try and work through it as best as you can, because the more you can start to understand what's going on and why it's happening, the easier math becomes. I mean, it really becomes a Sudoku puzzle where you slide in one piece and then the rest of them kind of start to fall into place. Okay? Really kind of push yourself. All right, next one. AC is 12. So that's going to make this 6 and 6. That's going to make this whole thing 12. Okay. QD, Q to D is 10. Okay. Find the length of QC. All right, so we're looking for this. And we know this is going to be 6 because these dashes tell us that all side lengths are equal. Oh, okay. So, if that's the case, we have a squared plus b squared equals c squared. That's the Pythagorean theorem. I'm going to say a is 6, b is x, and c is 10. Do we know that they are right angles is going to be the real question. But if I know BC is equal to DC, I don't think that helps us with the converse. If a point is equidistant from the endpoints of a segment, then it's on the perpendicular bisector of the segment. Yeah, so that would be like if we know D is equidistant from A to C, then it's on the perpendicular bisector. But how can we show that in this problem? That would be the trick. This is 10. This is 12. Huh. This is a conundrum. Well, let's talk about QC, because without having to write a proof, we would do 6 squared plus b squared equals 10 squared, just substituting our numbers in, and 36 plus b squared equals 100, so we're back to our Pythagorean triple again, which means b squared equals 64. Take the square roots, and b is going to equal 8. However, there's got to be something before that so that we can use the Pythagorean theorem. And it's going to be the perpendicular bisector piece, but I don't know. What am I missing? Whole thing's 12. 6 and 6, so PB bisects, but that doesn't tell me anything about that. QD is 10. That's going to be a good question. And if anyone out there in the chat knows why this is a right angle, my guess is it probably needed to be in here. Otherwise, I don't think we can. Well, we definitely can't use this because we need a right triangle in order to use the Pythagorean theorem. But I'm wondering if the converse of the perpendicular bisector could help us in this, but I don't think so. Man, that's going to be a question. I will come back with a follow-up video at some point, figuring out, because I'm going to ask one of my colleagues about this. I mean, this is how you ultimately do the problem. You're going to get 8, but whether or not we can use the Pythagorean theorem for this particular problem is what's going to be tricky. I know it's the intention to use the Pythagorean theorem, but the fact that we didn't have a right angle here, you can't just assume it. So, anyways, we want the answer of 8. I mean, that's ultimately what they're looking for, but kind of the justification to get us there is the tricky part. Okay, let's look at this. So there's 30 degrees here, and if this is 30 degrees, angle 4 is 90 degrees. Okay, and if that's 90, then I know angle 1 is 90 because those are vertical angles. So I know that's 90 degrees as well. Let's see. Maybe I'm missing some information. Find the measures of the angles in the diagram. No. Nope. No other information other than that. All right. Huh. So, once again, I believe information is missing off of our sheet where M should be parallel to N. Because if we know these are parallel, then I know angle 7 is equal to angle 5 by alternate interior angles. So this will be 30. I can't assume that yet. Wish I could. Although, if I know M and N are parallel, I do know that. So I could say, here's my Z shape by alternate interior angles. This angle is 90 degrees because of the Z shape, which you're like, okay, but I don't care about that one. But you're looking for angle 6, and angle 6 would help you by a 30, 60, 90 triangle, because all angles, so that would be the triangle, definition of a triangle. Angle 1 plus angle 2 plus angle 3 equal 180 in a triangle. Okay, so we have that. I would say 2 and 5 are congruent because of vertical angles. So whatever angle 5 is, angle 2 is going to be as well. Then we're looking at angle 3 should be equal to angle 6 because these are vertical angles as well, straight across from each other. So angle 6 is 60, which would make angle 3 60. And then angle 8. We would only know can we do alternate exterior angles somewhere? No. Man, I think you're going to have to know that X is parallel to Y as well. Because if you don't know that x is parallel to y, then you can't say this is 90 degrees to show that angle 8 is 60 degrees as well. So I do think there's a... And it happens all the time when worksheets, you're assuming something because you're working on something, but it's just not marked. And what should have been marked are like the double arrows on our lines to show that they're parallel to each other. You wouldn't have to say these two things because those double arrows indicate the parallels, but they should be on your picture, and they're not. So I'm making assumptions that I shouldn't be making. I'm pretty sure that's where we're going with it, but it doesn't make it acceptable in math. You have to know, and we as teachers should be telling you that these are parallel. So, yeah, that's it. I mean, we were working with perpendicular bisectors, which went pretty smooth. The converse and using the Pythagorean theorem went sort of okay. It's just we need to know these are right angles, and then we needed to know these are parallel lines. Once we know that piece of information, these are very straightforward questions. There's not a lot to set up and solve, but you gotta know that straightforwardness. All right. So anyways, I hope you enjoyed this video. I will look into both of these problems and come back and let you know that this should have been a 90-degree angle, and we should have told you these are parallels. That's going to be what I'm assuming is happening, that we just kind of didn't do as teachers on this worksheet. But maybe I'm completely missing something, and that's okay too. Mistakes and wrong answers are opportunities for growth and learning. I tell my students that all the time. Nobody's going to be perfect. We're going to make mistakes, so let's figure out what we did, how we made them, and not make them again. That's all. Once again, if you have questions, always throw them at me. I've got, I show it once in a while, but I got my Discord channel locked down. Put those questions right here in the questions tab, right at the public sections. When you join, please make sure you read through the rules, though, and react to them. Otherwise, you're going to sit here and not see any of the channels. And it's not that you don't have to, but you want to see all this other stuff. That's reacting to the rules. It's meaning you read them, follow directions, good to go. Until next time, keep mathing and keep asking questions. No matter who your teacher is, ask them questions. All right, love you all. See you next time.